Hello everyone, I am Amod and welcome back to my YouTube channel. In this video tutorial, we will learn about virtual threads in Java and how can we use this concept in our day-to-day automation testing. So before we understand virtual thread, let's understand what is a thread. So let me start with a real-time analogy first. Consider a restaurant kitchen, and this kitchen you can assume as a process or a program. If you have one cook in that kitchen, then that cook can prepare one dish at a time. Or we can say that orders will be processed one by one in a sequential manner. So obviously your process or kitchen is slow because it is taking time to deliver orders. But suppose if we have multiple cooks and they can prepare dishes in parallel. So obviously your kitchen can serve more requests and you can say your program or process or kitchen is faster. So in this example, a cook is a thread. So if you define a thread in a programming language, then we can say that a thread is the smallest unit of execution in a program. Oracle official document says that a thread is the smallest unit of processing that can be scheduled. It runs concurrently with and largely independently of other such units. So I hope you're clear what is thread. Now, there are two kinds of threads, platform threads and virtual threads in Java. So if you talk about platform thread, this is not specific to Java, but it is applicable in all the programming languages. So basically every program or process will have at least one thread which is called main thread, and any programming language may allow you to create extra thread apart from main thread. So basically when we create a thread, that is also called a traditional thread, which is basically OS managed thread. Let's see what Oracle document says about platform thread. So a platform thread is implemented as a thin wrapper around an operating system thread. And these threads are called platform threads because they rely on the operating system to manage execution, scheduling, and context switching. Further, it says a platform thread runs Java code on its underlying OS thread, and the platform thread captures its OS thread for the platform thread's entire lifetime. So basically, a platform thread is running on the OS thread, and OS thread will be blocked till the lifetime of platform thread. Because of this, the number of available platform thread is limited to the number of OS threads. So basically, each platform thread will take some memory in its stack, and your JVM may crash with higher number of threads. Same points, Oracle says that platform threads typically have a large thread stack and other resources that are maintained by the operating system. So they are basically suitable for running all types of tasks but maybe a limited resource because every thread is sharing the same resource. But since Java 21, we have something called virtual thread. So this virtual thread is a lightweight thread which is managed by JVM, not by operating system. Because of this, it is extremely cheap in memory and we can create thousands or millions of threads. A virtual thread is not tied to a specific OS thread. A virtual thread still runs code on the OS thread. However, when code running in a virtual thread calls a blocking IO operation, the Java runtime suspends the virtual thread until it can be resumed. The OS thread associated with the suspended virtual thread is now free to perform operations for the other virtual threads. This paragraph is important to understand how virtual thread works. So it says virtual threads are implemented in a similar way to the virtual memory. So to simulate a lot of memory, an operating system maps a large virtual address space to a limited amount of RAM. Similarly, to simulate a lot of threads, the Java runtime maps a large number of virtual threads to a small number of OS threads. In case of platform threads, one thread will be associated with one operating system thread. But in case of virtual thread, multiple virtual threads will be mapped to a small number of OS threads. It's not one to one. Now let's see how can we use virtual threads to do some automation tasks. So suppose you want to do some quick load testing of an API. Obviously we have other tools to perform load testing of an API, but we can use virtual threads to quickly do the load testing of API as well. Let's get started. So here I have simple get API which will give me this response with 200 status code. Now I want to do a load testing with 500 virtual threads. So here I have simple class with the main method, and to hit the API I'm going to use rest assured. So I will use rest assured, and we have simple get method, and I'm going to copy this API endpoint and paste in double quotes, and I will call then method and extract response. This I can store in a variable of type response, and let me sys out response status code. This is a very simple API call, and I'm going to run, so it should give me 200, which you can see on the console. Now I want to make 500 calls to this API, and for this I'm going to use virtual threads. So we have something called executors, which is coming from java.util.concurrent package. And here we have one method, new virtual thread per task executor, which is going to return me a executor service. So let me store into a variable of type executor service. So basically, in this statement, a new virtual thread will be created for each task submitted to this executor service. Since I need to create 500 virtual threads, so I'm going to call a for loop int I equal to 0, I less than 500, and I plus plus. In this executor service reference, we have one method called submit, and you can see it is accepting a task. So I'm going to use an anonymous function here, and within this anonymous function I'm going to have this code. So what will happen when this for loop will run, it is going to submit 500 tasks to this executor service, and this executor service will create one virtual thread for each task. And also you need to understand this submit is non-blocking. It is not waiting for this execution before iterating next. So basically it is quickly submitting the task to the executor service. And just to show that it is actually creating virtual threads, I can have something here request, and then it should append I and append the status code. It is giving error. It says that variable used in lambda expression should be final or effectively final. So for that I am simply going to create a variable, maybe int request id, and I will assign I to it. Now I can use this request id instead of I here. So once we have submitted all the tasks to the executor service, still we have two important methods to call. First one is executor service dot shutdown. So this method will initiate an orderly shutdown in which previously submitted tasks are executed, and it will not accept any new task. But this method does not wait for previously submitted task to complete execution. We need to use await termination to do that. Let me show you something first. I'm going to comment this line and run the program. You can see program is being terminated immediately because tasks were submitted and program did not wait for it to finish. That's why we need to explicitly start shutdown process by calling this shutdown method. But problem with this method is that this method will not wait for the already submitted task to complete. For that we need to use another method, await termination. If you click on this method, it says it blocks until all tasks have completed execution after a shutdown request. That means when we call the shutdown, then call await termination, then it will stop from shutting down till all the submitted tasks are completed. And this method is taking timeout and timeout unit. So here I can call again executor service dot await termination, maybe 10, and time unit I can use maybe seconds, and I can use 100 here. So maximum I am going to wait for 100 seconds. Now let me run this program. So we are printing the request ID, and maybe I should have some separator here. That's all. Add the semicolon here. It looks good. Let's run it quickly. So it is taking some time, but now we can see we have many things printed on the console and program has already terminated. So here you can see request 214 and then 200. So you can see these are not in sequence, right? That means you can understand multiple threads were used to hit the API. Maybe if you search for request 0, yeah, it is here, and it should be 499 as well. Yeah. So virtual thread is really helpful, which you can use to do a lot of tasks. One example I can give you, like suppose you have many links on your web page and you want to quickly check if all links are active or giving the response, then you can call or use this virtual thread concept to run them in no time. So I hope you like this concept, and if you use this concept in any of your scenario, you can comment on this video. So that's all in this video tutorial. If you have a doubt, please comment on this video. If you really like my videos, please like and subscribe and share with others. Thank you everyone.